Hello, third graders. Mr. Wojcik here, Technology. I hope you're doing well, and we're going to get started on our new lesson here in class. And that is talking about Turing Tumble. Turing Tumble is actually a computer. A computer is pretty big. We have some large computers, but we do have smaller computers, like phones, laptops, and iPads. The inside of the computer has a lot of stuff in it. As you can see this picture right here, the inside of this computer has all kinds of stuff in it. Whoops, and I did not want to do that. So, uh-oh, the computer is bogging down here. There we go. So I'll just leave it at this picture here. So there's all kinds of stuff in this computer, but the main component inside the computer, the component that costs the most, is probably one of the smallest pieces in the computer, and that's the processor. And that's what you're really paying for when you're buying a computer. Some of the other stuff really doesn't cost nearly as much as what this processor is, and that's probably one of the smallest parts in the computer. And that's what makes the computer seem like it's smart. And I say seem like it's smart because really, without you using that computer, the computer is just a piece of equipment. If it's not used, nothing really happens. But if you're using it, you're the one that makes the computer seem like it's very smart. So a processing chip, when we look at it a little bit closer, it looks like this here. So that's a pretty good view of it. And all of these dots you see here are wires, and they're either input wires or they're output wires. So an input would be maybe clicking on your mouse or wiggling your mouse. That's an input. Typing on your keyboard, touching your screen, if you have a touch screen, those are all inputs. You're telling the computer what to do and where to go. An output would be what you see on the screen. So if I'm using my keyboard to type, I'm seeing the letters on my screen as a result of that input. So the output would be the letters. Or if you click on a website, the output would be going to that website. So that's basically what a processor does. It processes your inputs and gives you an output. And then we have what, if I was to open that chip up and look inside of it, this is what you would see. Let's see if I can see a bigger picture of this. This is what I would see inside that chip right here. All these little wires and roads, they look like roads going to different outputs and inputs. And there are actually billions of wires in a processor. So your computer and your phones and in your bigger computers have billions of wires. And these wires in this processor, if you were to take a look at one piece of your hair, the wires in here, or the pathways in here, are about 1,000 times smaller than your hair. So imagine that. If you took a piece of hair and looked at it, the wires here are about 1,000 times smaller than a piece of hair. It's pretty amazing to even think about that we can create something like this and put it in a computer and it works great. So Turing Tumble, I'll have you using the simulator of Turing Tumble, and it looks like this. I'm going to clear this off here. And Turing Tumble looks a little different in my classroom because we have the physical version of it. So when you see towards the end of this lesson what the lesson looks like, you're going to see that Turing Tumble looks a little different than what's on my screen here. But they both work the same. We're going to talk about Turing Tumble and all the different parts. I'm not sure you can see these on the left-hand side of the screen or the right-hand side of the screen, but eventually you will. I will talk about them in my next lesson, though. All right, our next part of this lesson. I'll be right back. Hello, third graders again. Mr. Wojcik here. I really hope you can see the whole screen here. Fourth graders, when I recorded this, could not see all my tools, but then in the last part of the lesson, they could see all my tools. So bear with me if you can't see the tools. I'll explain them, and then you'll actually hopefully see them in the last part of the lesson. Not sure why they're not showing up in this second part of the video. Hopefully they are. and they should be. Here we go. The first tool is the hand or the pointing finger, and that's going to do a couple things. That's going to move your tools onto the simulator, the Turing Tumble simulator, and then also flip them, turn them around. And then here we go with the erase tool. The second button is the erase tool. That's going to take parts off your Turing Tumble. The first physical part that we have here is the ramp, and the ramp will allow the balls to travel down through Turing Tumble here to the turnstile. And I'll demonstrate that right now. So I'm going to take the hand tool. I have to reverse some of these. So this is going to drop the ball off the edge here. I don't want that. So I'm going to drop the ball from level to level. I'm going to turn this one as well. So to start this program, I can start it two different ways. I can press the arrow and it'll start my computer simulation, or I can press the turnstile and that will start it also. I only have to press it once because every time a ball comes down the ramp and goes through the turnstile, it's going to start another ball. So I'll start it from the top first. There we go. Oops, now I have a mistake there, so I have to fix that. So let me reset that and take my hand tool and change that one. Let's see, it's got to double check this a little more carefully. Oops, looks like I need to change all these. That's going to work like that. Okay, so now I think I have it correct. Here we go. So there we go. And the balls drop down to each level. You don't want a free falling ball where it skips a level. You want a turn style or a ramp or some kind of physical thing on each row, so the ball goes onto something for each row. The ball is just not going to freestyle like this ball here all the way down. We're not going to just let it freestyle because really that doesn't do anything for us, right? So we're not going to allow that to happen. So we want something on each row. All right, so I'm going to reset that, and I'll talk about how I reset it in just a little bit. If I wanted to erase some of these ramps, I'm going to click on the erase button and tap on erase. All right, so the next tool is the orange tool, and that's called the crossover tool. So if I drop a ball down here, it's going to go in here and cross over to this side. And if I had something coming down this side and a ball was going in here, it's going to cross over to the opposite side and do the opposites of the things. So let's take an example of that. Oop, press my hand tool. There we go. And you can see this ball is going to cross over to the other side, okay? And it's always going to cross over to the other side. There we go. All right, so I'm going to reset that. The next tool is called the interceptor tool, and the interceptor tool is going to stop your program. And you may need to stop your program for different or various reasons. And this tool here is going to stop my program and not allow it to get to the turnstile to let another ball release. All right, so that's what that one does. I'm going to delete or get rid of that one. There we go. Whoops. And now I'm going to have all kinds of balls dropping. There we go. All right, so now I have the next one, and the next one is called the bit, I believe. Let me get my paper here. Yep, the bit tool. And the bit tool is this tool here. And when the balls drop down to the bit tool, it's going to go to my crossover, and it's going to allow the ball to drop to the right, or it can switch and go to the left. Now I'm going to let it free fall, and again, we don't want it to free fall. That's one of my rules. But in this case, for demonstrations, we're going to let it free fall. But again, there's my switch, and it drops this way, and I can use that switch to make it drop the opposite way then. Right, so if I need the red and blue balls to switch or cross over, I can do that, and it just makes that the ability to those balls go different routes then. So that is the bit, and it switches the direction of the ball. The next is the gear, and I think I have enough room for the gear here to put it in. So the gear by itself isn't really going to, actually, I guess it did work. You can see it turned, but really with the gears, I need a gear tool, right? So this gear tool They both have to be pointing both the same way, and this gear tool will allow these things to spin and turn and push the balls the opposite way again. Let me reset that so you can see that working. There we go. So again, the gear tool is going to the gears don't really interact with the board at all. It is the gear bit tool, the purple one, that works just like bits, the blue one, but they always point the same way. So these are always pointing the same way, right? So when it turns, they're pointing to the right. When it hits it again, they're both going to be pointing to the left. All right, so that is how that tool works. And let me stop this or reset it. So your simulator has some different options that you have that we don't have in class. So we have all these options in class, but we do not have the option of adding another drop tool like this one here. So you can add another drop tool and put more balls on it and have different drop points on your board. So we don't have that option here in class. I'm going to erase that, so we don't need that right now. We have turnstiles. If you want to add other turnstiles in different parts of the board, you could, where you could have more balls releasing, not just down here, but at different places of the board. You could experiment with that. I'm not sure why you would, but if you want to experiment and have all kinds of balls dropping, you could do that. All right, and then this one here is called the side tool, and basically that allows the ball to drop down straight down. So if a ball is coming down, it'll drop straight down, and then you can catch it onto some ramps from below here. You can have six of these side tools in a row, up to 6. Then we have the slope. So the slope basically does the same thing, but again, it's a slope. So it allows that ball to go down on an angle, and you can change that slope's direction by clicking on the hand. And now I can change that the slope's direction. So if I click in the middle, oops, it should change the whole thing, and it does not. So it should, but I can also move it. And I can get that slope to be a little bit less also. So there we go. So I can get it to be a tiny bit less. Let's see if I can get it to go up here. Nope, it won't. So you can experiment with slope if you want, and it just removes the ramps and the balls go down faster. Let's try one. No, didn't work because I have a free fall going. There we go. All right, so I just wanted to try it. All right, and then on the other side, we have this arrow, and this is the size board I have, and this is the exact size board, the physical board we have in class. So I'm just going to click on this. It's going to clear everything off my board. And then I can go to a bigger size board, medium size. Now it looks like it shrank, but actually I have more pegs to put things on, and I can go to the large board then as well. So I have even more pegs to put things on, so I can make my simulations, my computer simulations, even bigger. And then I have the largest board here. All right, so I'm going to go back to the original board like we have in class, and then this here, the 3 balls, the X's on, that just gets rid of all your balls. So I'm going to add new balls in here. So if I drop blue balls in, I don't have to change the color. It automatically changes to red when I drop them in. Looks like it's blue, but it automatically changes to red. And then this button here is a download button. I can download a picture of my simulation. So you can upload it to Seesaw if you want, or just take a picture of it and upload it to Seesaw. And then this would be uploading my whole simulation, so I can save it to my computer, the bottom one here. This button here turns your ramps and everything into a different look. It is called, I forgot the name of it. It is called where'd it go here? Schematic action. So toggles everything to make it look a little different. The tools still do the same thing. The tools all still do the same thing. They just look different. So I like the other look better. So it just makes more sense to me, but that's just what that tool does. They all do the same thing as what the normal tools look like. They just look different. That's all. This button is zoom in. The bottom below it obviously is zoom out. The minus sign is zoom out. Plus sign is zoom in. If you're zoomed in, you can click the 4 arrows to return it to its normal size or original size. The rabbit makes your simulation run faster. The snail makes your simulation run slower. And again, the 2 arrows that are pointing up, once your balls are all at the bottom. So once your balls are all at the bottom of the simulator, you can press the up arrow and it resets your balls to the top. All right. And let's see here. We have our 2 icons down here, the question mark and the cat, it looks like. Those take you to websites about, just gives you maybe some lessons and some things you can do with Turing Tumble. And then the heart actually takes you to the Turing Tumble website. You don't really need to use those, but if you want to do some exploring and learn a little bit more or order the physical Turing Tumble, you sure could. That's where you would order it at. All right, so that's all I have for how Turing Tumble works and the tools. Next, we'll be getting into the lesson. So I have to get that set up, and I will record that in just a few minutes. I'll see you in a bit. Hello, third graders. Mr. Wojcik here, and we're going to get started with lesson number 1. I'm going to help you out with lesson number 1. I'm going to clear this off. There we go. And I think we are all set, except for I need to change that back to normal. All right, so my simulator, compared to what the lesson looks like, the boards or the Turing Tumble board looks different, but they do act the same. Just know that for what you see on my piece of paper for the lesson, the Turing Tumble board will look a little different than your simulator screen, but they do act the same. So here we go. First lesson is going to, where to go? Hold on. First lesson is going to look like this. And it says your objective is to make all the blue balls and only the blue balls reach the end. Required output are just the blue balls. Those are supposed to be blue, but this is a black and white piece of paper. All right, so here we go. Your starting setup. They're always going to give you a starting setup on how you're supposed to set up your area. And you can see at the top here, and the bottom will look different than your simulator on your screen. That is okay. This is what our boards look like in class, our physical boards. So you don't have that option. You have the computer simulator. So just go ahead and set it up just the way it looks. And I'll demonstrate that. So we're going to start out with 1, 2, 3, 4, 5, 6 ramps. And your available parts that they want you to use is an additional 4 ramps. So let's set the board up first so it looks like this. Let me get back to my simulator. There we go. And now I'm going to use my tools. I'm going to put a ramp here. 1, 2, 3, 4, 5. And I have to flip this ramp. So the ball drops into this ramp, goes down to this one. Now I need to figure out where those other 4 go. I have 4 available parts that I can use. 4 available ramps only. So I'm missing a ramp on this row. I'm missing a ramp on this row. On this row a ramp is missing, and also this row. So those are where I need to put my ramps. I have to figure out where to put them. If I put it here, I suppose I could, but 1, 2, 3, 4, that might work actually. Or I could put it over here. So in coding and programming, boys and girls, or problem solving, sometimes there's multiple answers. So you just have to figure out what answer you want. I showed my 4th graders a different way. I think I'm going to show you a different way how to solve this problem than the way I showed the 4th graders. So there's 1, 2, 3, 4 additional ramps. I can't use any more. Even though I have more available to me, I'm only supposed to use 4, right? So I'm going to flip some of these ramps around so it can work. So this ramp's going to drop to this ramp's going to drop to this ramp, and then it's going to go the opposite direction here. So that means I have to flip this ramp around, flip this ramp around, flip this ramp around. And I could flip this ramp around, but I don't necessarily have to because this one's going to drop into here and then it's going to drop into here and go down. I could do either way. If I go this way with it, it's going to make the simulation run a bit slower. And this way will run the simulation a bit faster. So whatever way I want to do it, I think I'm going to go this way. So to start my simulation, I can start it one of two ways. I could start up here with this just by hovering over these balls, the blue balls, and pressing the arrow once. Or I can turn the turnstile once, which will release a blue ball. And I don't have to touch anything after that. I can just run the simulation to see if my simulation works. Remember, the goal is not to let any of them free fall like this. You don't want the balls free falling, not touching anything. They have to touch something on each row. So I'm going to reset that. So that's free falling. We don't want any free falling. So let's see if I have my simulation correct. Here we go. And they're not free falling. They're hitting a ramp on each row. And it looks like my simulation is working. I'm only getting blue balls and they are not free falling. So this should, I'll just let it run all the way through. Notice I'm not touching anything. As soon as my ball touches a turnstile, it releases another ball on top. And there we go. Perfect. All right, and when you're finished, when all the balls are done running their simulation, their computer simulation, you're going to press these two up arrows on the right-hand side, and it resets the balls on top. Okay, so that's your first challenge. Pretty simple. Second challenge, we'll go through that. Oops. Second challenge, where's my PDF? There it is, I think. Uh-oh. Let's see here, I'm gonna move that, there we go. There's my PDF. Oh, that was not my PDF. I lost my PDF. Hold on, there we go. There we go. All right, so my PDF, that's my first lesson, and you're just gonna scroll down to the second lesson, practice puzzle A for challenge 2. Again, make all the blue balls and only the blue balls reach the end. Required output, just the blue balls. All right, so again, you have your simulation. Now they set it up a little different, so you'll have to set up your board just like this, and then figure out where those 3 pieces, the available parts, they want you to use 3 additional pieces to make this simulation work correctly, to get only blue balls again. And it doesn't look like this one has multiple answers to it. Looks like there's just one answer to me. So you're just going to figure that out and run that simulation and see if you can get only blue balls. Now, if you want to do the opposite on this one and just get only red balls and set this one up as just the opposite, feel free, go ahead and try that. So, but you would have to set it up so it's opposite of this to get only red balls. And then you're going to go to the next lesson. And these lessons should go fairly fast. You're going to make all the blue balls and only the blue balls reach the end. Required output, only the blue balls. And now you have 5 available parts, 5 available ramps to add on to this computer program. And you're going to set it up by starting with these first 6 ramps, and then you're going to add the final 5 ramps. And for the next one, I think there's one more after this. Start the machine by releasing the blue ball. The blue ball should then release the red ball. So now you're releasing blue and red balls. And you got to figure out how to finish this program. And you're getting required output blue and then red balls. So they don't give you much of a hint here. They start you out by getting you set up with your ramps, and you can use just these 8 parts right here. So it looks like 2 balls are required, 1 blue, 1 red is what they're looking for. And then the last lesson, release 1 blue ball and then all of the red balls. All right, so now it gets a little tougher. So they set you up with 2 ramps to start with, But then they put 4 ramps down here, and you can use 6 ramps. And again, they want 1 blue ball released at the bottom, and all the rest that are released are all the red balls. So 1 blue ball, 1 red ball. So a little more challenging. So you have to figure out how to get 1 blue ball down, and then all the rest of the balls are going to be blue. And you have to figure out how to complete that program. And if you ever have any questions, remember I am online from 10 to 12 each Monday. So we can go over some of these simulations together if you're having some trouble, or if you just want to jump online and show me what you're working on for Turing Tumble. I would love to do that. Or if you have any other issues or questions about schoolwork that you may have, I can try to help you out with that as well. All right, I will post this and have fun with it and see how far you can get. And then again, just play around with it too after you do all the lessons. Play around with it, see what you can create, and like I said, just have fun with it. Have a great day. We'll talk to you later. Figure out how to stop this here.